Good morning, and welcome to our 10th annual Campus Technology Innovator Awards. I'm Rhea Kelly. I'm executive editor for Campus Technology magazine. And today's ceremony, we're recognizing 11 institutions for their efforts to better serve teaching, learning, campus administration via technology. Worthy of recognition, too, are the vendors and products that help make these projects a reality. I'd also like to recognize Hire One, who's the official sponsor for our awards program, for their ongoing support. Thank you also to Mary Grush, Campus Technology's editor-at-large. She is the head of our Innovators Judging Committee. These individuals graciously volunteered their time and their expertise, and their input was invaluable part of our winner selection process. Handing out the awards today are Ann Armstrong, sitting behind me. She's co-president and chief content officer for the 1105 Media Public Sector Media Group, and David Harris, the senior account executive for Hire One. And as I name each institution, we'd like a representative from the project to please come up to the stage and receive your award. So on to our first winner. In the category of Administrative Systems, Kennesaw State University. When the University System of Georgia announced a partnership with Coursera last year, Kennesaw State saw an opportunity to give more learners a pathway to higher education, as well as drive enrollment for the university's degree programs. The institution operationalized credit awards for MOOC participants by creating a virtual assessment center, which processes fee-based portfolio submissions from MOOC students and routes them to departments for evaluation. Congratulations, Kennesaw State. Also in the category of Administrative Systems, the City Colleges of Chicago. Looking to better serve its large student population, the City Colleges of Chicago system reinvented its decision-making with a data democracy culture, empowering all faculty and staff with a flexible reporting and data analytics system. Fully interactive reports can be manipulated with drag and drop simplicity, ensuring that each employee has truly relevant data across multiple roles at his fingertips. Congratulations, City Colleges of Chicago. Next, in the category of Student Systems and Services, the PAR framework. By creating a single federated dataset of more than 1.8 million normalized de-identified student records, this multi-institutional effort provides a valuable resource supporting predictive analytics for student success and linking interventions to specific risk factors. Its student success matrix and PAR common data definitions have been openly licensed for use by higher ed institutions. Congratulations, PAR. Also in the category of Student Systems and Services, Georgia Institute of Technology. The AMAC Accessibility Solutions and Research Center is the only full-service center in the country that supplies repositories of accessible digital textbook files, Braille, assistive software, and remote captioning for students with disabilities, as well as training and consulting services. It serves 22 technical colleges and 59 universities in the state of Georgia and does post-production work for about 275 universities nationwide. Congratulations, Georgia Tech. Also in the category of Student Systems and Services, the University of Washington. To keep students' academic plans on track, the University of Washington developed open source software that integrates previously siloed administrative functions such as degree audit and articulation, student lifecycle and recruitment, registration, and advising. The ultimate goal is to incorporate my plan into Koali Student. Congratulations, University of Washington. Next, in the category of teaching and learning, Marist College. Marist The Fold is a student-designed and student-delivered academic learning environment combining a website, MOOC, and open online community. Supported by the cloud technology that forms the college's academic community cloud, The Fold will serve as a model for the institution's strategic cloud initiative going forward. Congratulations, Marist College. Next, in the category of leadership, governance, and policy, New York University's Silver School of Social Work. Torch Tech is a community-led group for fostering collaboration, building relationships, sharing information, and impacting IT strategy across a large university with a highly distributed IT structure. Since its inception, Torch Tech has organized 7 events with participation from 45 NYU organizations and 550 people. The effort resulted in the first ever university IT project directory, IT communities of practice, and the start of an IT-specific membership directory. Congratulations, NYU Silver. Also in the category of leadership, governance, and policy, the University of Oklahoma. The One University Digital Initiative is a technology strategy for a broad campaign to ensure the university will take its place in the digital realm. Projects include Janix, an interactive learning community, OpenStax, an open educational resource textbook partner, and iPad programs in several of OU's colleges. To help maintain momentum, a reinvented campus bookstore showcases the initiative's cutting-edge technologies, and a large steering committee provides lasting leadership. Congratulations, University of Oklahoma. Next, in the category of IT infrastructure and systems, Penn State University. Penn State researcher Howard Salas created a web portal that provides a streamlined tool for a complex process, DNA sequencing. When the DNA compiler became so popular that server queues reached 80 to 90 jobs, frequently requiring more than 100 compute hours each, he moved it to the cloud, turning it into a highly scalable, on-demand system that serves scientists all over the world without taxing institutional resources. Dr. Salas could not attend today. Congratulations, Penn State. Also in the category of IT infrastructure and systems, the University of Denver. The University of Denver saw its library renovation as an opportunity for a fundamental rethinking of the use of space and technology to support the new ways people work and learn in a digital environment. Penrose Library has been transformed into a technology-rich learning commons that is the intellectual heart of the campus, chock full of collaboration spaces, high-tech meeting rooms, academic support centers, social areas, and more. Project lead Nancy Allen could not attend today. Congratulations, University of Denver. And finally, in the category of education futurists, NYU Stern School of Business. NYU Stern transformed its orientation process for new students, moving from a traditionally passive lecture and presentation process to a 2-day program focused on experiential collaborative learning and cutting-edge tech tools. Among the goals, to expose students to authentic learning that maintains a balance between creative intuition and analytical rigor, challenge students to think disruptively, capture first-person experiences with wearable technologies, and inspire students to envision new possibilities for their future careers. Congratulations, NYU Stern. Be sure to check out the coverage of these terrific projects in our July issue and on our website. You also have the opportunity to meet many of these innovators in the Tech Talk sessions today at 10:45, as well as in the poster session this afternoon in the exhibit hall. So congratulations again to all our innovators. And now I'm delighted to introduce you to this morning's keynote. Dr. Anant Agarwal, the CEO of edX, the online learning destination founded by Harvard and MIT. He taught the first edX course on circuits and electronics from MIT, which drew 155,000 students from 162 countries. He has served as the director of CSAIL, MIT's Computer Science and Artificial Intelligence Laboratory, and is professor of Electrical Engineering and Computer Science at MIT. Dr. Agarwal is a successful serial entrepreneur, having co-founded several companies, including Tylera Corporation, which created the Tile multi-core processor, and Virtual Machine Works. He won the Maurice Wilkes Prize for Computer Architecture and MIT's Smolin and Jameson Prizes for Teaching. He also has a Guinness World Record for the world's largest microphone array. So please join me in welcoming Dr. Anant Agarwal.
Thank you. So I'm not sure why everybody laughs when we talk about the Guinness World Record. It's serious stuff. So I'm really delighted to be here this morning and brainstorm about how we can transform education. And as part of that, also want to introduce edX, an online learning destination to you all, and talk about the ways in which we can bring technology into the campus and really reinvent education both on campuses and beyond. If you look at the way education has been, this is a classroom from MIT, I don't know, 50, 60 years ago. Heck, it could have been 200 years ago. It could have been 2 years ago. So what's interesting about that? Everything around us has changed. Absolutely everything. Communications has changed, healthcare has changed, but education hasn't. If you imagine surgery, a few hundred years ago, they would hit you on the head with a hammer, and then they would quickly operate on you before you came to. But today, with laparoscopic surgery, you're in and out, and you come in with a gallbladder and you're out without one, and it's all done with a little laparoscopic thing. Completely changed, but education still stays the same. It is actually pretty shocking and pathetic that an education system and the way we educate learners has just absolutely not changed in hundreds of years. But our learners have changed. Our millennial generation learns completely differently. They speak a different language. They learn differently. They don't like being herded at the same place at the same time, particularly early in the morning. They do all of the new things that we never heard about. Even 10 years ago, the whole texting and tweeting and Snapchatting and WhatsApping, some of these things that I just heard about, a few years ago. The way I hear about them is my daughter, who just turned 15, telling me, Dad, you didn't hear about this? And the whole thing was invented. That tool may have been invented 2 months ago, but it's a whole new world. They study. This is their favorite mode of study. They don't like being herded into nice little rows in a classroom. They like to be completely flexible. It's very hard to communicate with teenagers unless you're texting and tweeting. And I'm just compelled to tell you another LOL joke. How many of you have heard an LOL joke in the past? None of you have heard an LOL joke? We're all dating ourselves, folks. How many of you want to hear an LOL joke? All right. So I'm from our generation, and I thought LOL means lots of love. And so there are lots of LOL jokes. So my daughter went to camp last week, and in upstate New York. And so I texted her saying, make sure to call me every night. And she texted back, LOL. I said, great, she's going to call me every night. And, it's been a week. I'm still waiting. And then I go complain to my son. I said, look at this sequence of text messages. And Anisha said she's going to text me. She kind of implicitly agreed to call me every night. He said, "Do you know what LOL means?" I said, "Yeah, lots of love." He said, "Oh, you idiot, Dad." He said, "It means laugh out loud." So anyway, so you heard one more LOL joke. So this is a new generation. Okay, they think, talk, act differently. They have different three-letter acronyms than we do. Yet we insist on teaching in the same way that we have. So we are looking to really change all of this. And edX is a learning destination. edX is a nonprofit. We are the only nonprofit MOOC provider. We were founded by Harvard and MIT about 2.5 years ago with a $60 million initial investment. So we have, the way we work is that we have university partners, over 50 partners at this point, including great universities from all over the world, like Berkeley in California, or University of Washington, or Tsinghua in China, Boston University, that offer these great courses on our platform for free. And if you're a learner anywhere in the world, you can come in and take these courses. So here, for example, you see highlighted a course from Tsinghua, for example. We have a three-part mission. The first one is we want to increase access to education for students all over the world. Second is that we want to improve the quality of education on campuses and beyond. It's not enough, if all you do is create videos and multiple choice and throw them out there, you can still increase access to education because a lot of people around the world don't even have that. But that would fall way short of our goals. We really want to improve the overall quality of educations, even at the highest quality education campuses in the country and in the world. So we have a really ambitious goal. The third part of our mission is improving education through research. So we are collecting the big data of learning on our platform, and working with our partners, we want to do research and mine this big data to understand how students learn. And I'll give you just one or two little examples towards the end of the talk that focuses on how we can use this data to actually improve the quality of learning. In other words, much like Google might improve the front page of its website, we can use the very same technologies like A/B testing and so on to turn educators into continuous experimenters that can improve the quality of learning over time. So really bring in technology and world-class, cutting-edge engineering practice. I hate to use the word engineering in an education audience because to me, engineering is a good thing. It's a good word, so just assume it's a good thing. It's about improvement. And so I want to bring engineering into education so that as educators, we can all look to continually improve and experiment with what we do. So I'll talk about how at edX we're trying to do all of these three things. And it's very apropos that I'm talking about this as campus technology, because a large part of what we are is about technology and the campus. So let's start with improving access to quality education. So as our introduction very quickly mentioned, one reason why destinations like edX and so on have become so popular is just the sheer numbers of people that are learners around the world that are registering for these courses. So we are a MOOC provider where at our destination, learners can come in and take these free courses. So the MIT X Circuits in Electronics course was the first course on our platform. We announced this about 2.5 years ago. And with hardly a marketing budget, before we knew it, we had 155,000 students from 162 countries sign up for the course. That is a big number. For those of you who are wondering, 155,000 is a big number. And let me put that in context. That number is bigger than the total number of alumni of MIT in its 150-year history. And this was a number of people that registered for this course when we announced it. 7,200 students. This is an MIT hard course. Remember, we're not about videos and multiple choice. In fact, in this first course, to make a point, we did not have multiple choice on our platform. Our platform did not support multiple choice. Because it was funny, when we introduced this course, I was on a panel And I was asked by, there was a journalist on the panel who said, oh yeah, but this is all junk, it's been done, with the videos and multiple choice, who cares? So I said, we actually do not have multiple choice on our platform. We were making a point that we did not want multiple choice because there are a number of ways in which the multiple choice falls short of a really good learning experience. Over time, a lot of professors complained, and so we did, kicking and screaming, we added multiple choice as one of the problem type options to our platform. So this was a quality course. It was of similar rigor to the campus course that I teach. And 7,200 students from all over the world passed this course. Now, 7,200 is also a big number. This number is bigger than the total number of students I would teach at MIT, even if I were to teach twice each year for 40 years. So these are big numbers. And these are rigorous and high-quality courses, and I encourage you to go to edX.org and try out some of these courses. We have a course called Demo 101 on the front page. I would encourage you to go check out that course to give you a sense of the kinds of things you will see in courses. We have virtual online labs. You could do all kinds of things using gamification and online laboratories. There's a lot of we bring social into education, and I'll talk some more about that in a few minutes. To give you a few quick numbers, over the past 2.5 years, we now have about over 2.5 million students on our platform from every single country in the world. We have about 225 courses, and these courses range in languages from French to Hindi to Mandarin to a number of languages. And the courses themselves range from the humanities to arts, music, engineering, computer science, law, medicine, public health, really spanning a range of subjects. All the numbers aside, it is also very interesting to look at each of these learners. And Claude McKendy is one of my favorites. Today he's 28 years old, and so he was about 10 years ago when he was 18. He was in a family of 14 in DRC, the Democratic Republic of Congo. And from there, he went to University of Cape Town in South Africa to get his bachelor's degree in computer science. He was a family of 14, but unfortunately in his first year, his father passes away, and he could not pay his fees anymore. So he had to leave school after the first year, and then he's been working in Cape Town for 10 years. But now when these free courses, and some of just really first-class courses from places like Berkeley and BU and Harvard and so on are available online, he's now going back and taking these courses online and getting back to his education. And this is just one story. And there's you see pictures of a number of students. And what's amazing is that every student has an incredible story. We work on credentialing. You can take a course for free. You can audit the course. It's free. You can even sign up to get an honor code certificate, which is also free. You can sign up for a verified certificate, and where we check and authenticate your ID and so on and so forth. And for that, there is a small fee on the order of the cost of a textbook. We've also launched what are called X series. X series are, think of that as a program. It's a sequence of courses that you can take in a given discipline. So for example, we have an X series in computer science. It's 7 courses from MIT in Foundations of Computer Science. You take a sequence like that, you get a certificate at the end of it saying that you've passed the sequence of courses, and it gives you, think of it as a little minor. We've heard a lot about the pass rates and so on in some of these courses. People come in and take these courses, and different people have different motivations in taking these courses. And it turns out that for those students who sign up for either an audit track or the free honor code track, the pass rates in these rigorous courses tends to be about 5%. This means that only 1 in 20 students is either serious enough about the course to complete the course, or can cut it and pass the exams and so on. There are very rigorous assessments throughout. and earn a honor code certificate. So there's been recently a lot of hand-wringing in the press and so on about, oh, MOOCs and online learning is useless. There's only a 5% pass rate. But the more important number to look at is when people put even a little bit of skin in the game, when they sign up and they indicate their seriousness about taking the course and put down even $25 or $50 to pay for a verified certificate, suddenly the pass rates go substantially up. So the pass rates end up at about 60% as a fraction of those students that have paid a small fee and who pass the course. 60% is also a big number. It turns out that 60% is higher than the average pass rate from the US universities put together. That's not bad. The other thing we did, as I mentioned before, we are a nonprofit, and we behave like a nonprofit. And as a nonprofit, what does it mean to behave like a nonprofit? Behaving like a nonprofit means that you make it a habit to give things away for free. And so what we did, in addition to the courses being available for free, we've also made our platform available for free to the world. So about over a year ago, we open sourced all of our technology. The entire platform was made available. The source code can be downloaded. If you go to openedx.org, you can go there and download every bit of our code. The entire code base. And we have some pretty sophisticated technologies, including AI technology that uses machine learning that can grade open-ended responses like essays and so on. All of that stuff is completely open sourced. And so what's been amazing is that when you give things away for free, you suddenly find that all kinds of people adopt it. The free is very powerful. And so you won't believe who the first adopter was. The first adopter was China. So Tsinghua, the Ministry of Education in China, launched Shuetang X. So Shuetang X means a school X in China. And with edX, everything edX has an X next to it, so they called it Shuetang X. And they took OpenEdX and they launched a Chinese national platform. Stanford also decided they preferred a nonprofit open source approach to online learning. And so they launched class.stanford.edu using OpenEdX. And they've become one of the biggest partners of OpenEdX and contributors to the open source platform. The France Ministry of Education launched France Université Numérique with a nice little acronym, FUN. Education should be fun. And using OpenEdX. Queen Rania from Jordan and the Queen Rania Foundation launched EDROC. And just last week, we announced a partnership with Saudi Arabia. They launched a platform for the Saudi and the Middle East population using OpenEdX. We also partnered with Google, who are also developing and adding features to the open source code. And we continue to work with about a dozen other nations that are in the process of launching national infrastructures using the OpenEdX learning platform. So from a lark, where we just announced this one course 2.5 years ago, this seems to be fast becoming a movement around the world where countries are now adopting online learning to make it available to their populations. So that's about access. So in terms of increasing access to education, people can come to edX.org and take these courses. At the same time, by making the platform open source, people around the world are taking our platform and running it themselves and putting up courses that they care about. They don't have to come and take courses from edX partners. They can run the platform themselves. They can create their own courses in their own languages and be completely independent. I mentioned we have 2.5 million students on the edX platform itself. And already within the space of 1 year, the open source platforms around the world using OpenEdX today have more than 1 million students on them. So really this approach that we've taken is somewhat of a federated, decentralized approach to really spread access to education throughout the world. Next, let me talk about what do we think we can improve education, just the quality of education, both on campuses and online. And let me describe 4 proof points as to why we think we can improve educational quality. So the first one is the concept of active learning. And before I do this, a lot of the MOOC aficionados will talk about how a lot of what's happening in the MOOC world is all this new radical stuff. It is radical, but frankly, it's not new. And education researchers have known about this stuff for decades. Now, online learning has been around for 30 years, and each of the proof points that I'm going to give you has been research that's been published by educators 10, 20, 30, 40, even 40 years ago. And so a lot of what we're doing is really not really new. However, what we're doing is we're applying technology and making those ideas more scalable and available by applying technologies. So one idea is active learning. So what's this? So if in the classroom today, you go in and you sit in a 1-hour lecture. Okay, you may fall asleep at the 7th minute, or you may not follow the professor. It's one size fits all. But really, that's the model. It's very passive kind of learning. On edX, what we do is we replace the lecture with what we call a learning sequence. And even on the platform, we've developed user interface elements that reflect this kind of learning. So you notice this little ribbon up here where that ribbon represents a learning sequence. It replaces a lecture. And so a learning sequence, as the name implies, is a sequence. It's a sequence of short videos, 5-6 minute videos, interleaved with interactive exercises. Okay, so I can have a video, then have some interaction. I can give you a little exercise. I can show you another video, and then what I could do is ask you to go and have a discussion forum there. So it's really activities interspersed with videos where you are transferring content to the learner. So this form of learning, where you're actively engaging the learner, is called active learning. And active learning has been known to improve learning outcomes, and there's a landmark paper from 1972 by Craig and Lockhart. How many of you here have heard of this paper before? Very few. So I really encourage you all to read this paper. I myself, it is pretty shocking. I've been an educator, been teaching at MIT since about 26 years, and I've never read a paper on education. Isn't it shocking that we've been doing this thing for decades, and somehow it never occurred to me to go read a paper to see how I could do it better. It boggles my mind as to how sadly we've ill-treated education. And so here, Craig and Lockhart in '72 demonstrated that if you engage the student, and through this form called active learning, they really were the originator of the concept of active learning, although they did not name it at that time. They really showed that this kind of active learning can improve learning outcomes. And I'll show you some data that definitely justifies that thinking. The other thing is self-paced learning. So here's a little video by using a Salman Khan style tablet capture. And the beauty of this is, unlike a lecture, students absolutely love this. They love the flexibility. I mean, they've grown up watching YouTube videos. They've grown up being able to watch and listen to things whenever they like. And with videos explaining concepts, students absolutely love the pause and rewind button. Heck, you can even mute the professor. And in fact, when I taught a blended class at MIT with my own course, it turned out that 2/3 of the students would actually mute me and read the transcript on the right-hand side. They all want to do this very, very flexibly. Excuse me. So with the videos, people can pause and rewind, and they can do this as many times as they like. And there again, a study by Mayer has shown that if students were allowed to pace themselves, that again improves learning outcomes. Again, this has been known for a long time. So why do we still bring students into a lecture and don't give them a rewind button? The next is instant feedback. This is the third proof point. So we give homeworks, we give our homeworks, and students submit the homeworks to us, and if they're lucky, they get it back 2 weeks later. They've forgotten all about the homework. So what we can do by using computing technology is provide for instant feedback, online grading, computerized assessments, and instant feedback. And trust me, I promise you, we can do a lot more than multiple choice. And so here, I'll just give you a little example. So on our platform, we can grade chemical equations. I'll show you an example of chemical equations. We can grade matrices, differential equations in the engineering fields. We can grade a number of, we can image responses and so on. Today we can use machine learning. We can also grade both paragraph answers, text answers, and even essays. And in fact, there's an article in the Chronicle of Higher Ed that interviewed a number of professors, including Professor Bonavec from the UT Austin, that used this kind of open response essay grading in his globalization course from the philosophy department. And he liked it so much, he's now going to use it on campus. And so we're developing the new technologies that really sound like Star Trek or sound like AI. Heck, we're using AI. And so, and you can really bring them to bear on education and solve some really hard problems that we've been facing all this time. So I'll show you a quick little video where a student can enter a chemical equation as an answer, and the system will automatically grade it. So you enter a chemical equation, and oops, they got it wrong. Instant feedback, they try again, ultimately they get it right. And this makes learning very much like a video game where instant feedback is known to be one of the most powerful elements of gamification. And we are seeing that. Students tell us they're working much harder on problem sets because they're getting the instant feedback. And in fact, many students tell us that they go to bed at night dreaming of that little green check mark. When's the last time our children dreamt of homework? So, and in fact, the green check mark has become so incredibly popular that we found a meme on the web. This is that awesome moment when you get the green check mark for all your answers at the first attempt. So as an educator, you've arrived when something that you were involved in creating has reached meme status. So this is, this is, people like me and many of you won't appreciate this. But I saw this silly little character, and someone showed me this, and I said, yeah, what's the big deal? It looks pretty silly. But then when my daughter saw it, she said, whoa, this is amazing. So trust me, the millennial generation thinks this is really amazing. The next thing we can do is, a lot of people say, yeah, but you can't do labs with online learning. How do you do the hands-on stuff? Well, we can use gamification technology. We can use simulation technology to create virtual labs. So today we have virtual labs in circuits and physics and biology and chemistry and so on and so forth. We can do a lot of these things completely online, and where students can do the experiments multiple times. And it's challenging to introduce the sense of smell, but I'm sure you wait a few years, we'll solve that problem too. But so I'll give you a quick little example of, this is from the Science of Cooking course from Harvard. And I'll show you a little demo where students can pick the kind of meat they want to cook. They can pick the thickness of meat, the amount of the time to cook on each side. And once they've cooked, and they can simulate cooking the piece of meat. And then they can kind of go around and check temperature profiles and composition and so on, all completely virtually. So I'll show you a quick little demo here. Pick the type of meat, pick the thickness. So it even sizzles. And then they can go around and they can explore the temperature profiles and things like that. And so this course is attempting to teach physics and chemistry and biology through cooking and so on. So it's a really fun course. And the simulator was each of these online simulators are by and large viewed by students as something they really, really enjoy in the course. The fifth proof point I want to provide, the last one is peer learning, where students can also learn from each other. And so the discussion forum is a big part of the process, where you wonder if you have 150,000 students in your class, how do you answer questions? And the trick is that you don't. You do answer a few questions, but really what happens is that students are asking questions, and before you know it, other students are jumping in and answering the questions, and students learn by teaching. And this whole discussion forum and bringing the social into learning is absolutely amazing. So what we do now is that next to every video or next to every exercise, the instructor can embed a discussion forum right there. So students can be discussing while they are watching a video. So move completely from the model where in classrooms, I know a lot of professors that ban the use of iPads and other devices and so on. And here what we are saying is, no, you should be discussing things. You should be texting and whatever. And we actually put it into interface so that they can be discussing with other students while they're watching and learning content. And learning from each other is amazing. In fact, there's I'm jumping ahead here a little bit, but from the big data that we're gathering from this, Lori Breslau from MIT and Andrew Hoare from Harvard did a study where they found a much higher correlation, a correlation between students that passed the course and students that worked in groups. So those who were more involved with working in a group had a better chance of success than students who worked alone. So let's bring the social into learning. And our kids are social. I mean, they're on the social thing all the time. So why don't we bring social into learning? Okay, so that's hopefully give you a sense with these 4 or 5 technologies and ideas how we can actually improve the learning both on campus through online technologies. Next, let me talk about how we can bring this to campus. So what we can do is that you can, of course, teach completely online. But the question is, how do we do this on campus? And the key idea there is that you create a blended model where you blend the best of online and in person. So here's an example. So we did a pilot about 2 years ago with San Jose State University, where Professor Khosrow Gadiri at San Jose State took as a pilot our circuits and electronics course and blended the classroom. So this is a picture from the actual class. This was in fall 2012. So he had students watch the videos and do some of the practice exercises before they came to class. In class, they would sit down in groups of 3. He would answer their questions. And they would problem solve in groups and do some work together. The results were absolutely staggering. So traditionally, this course had a failure rate of about 40%. So about 60% would pass the course. But in this blended model class, staggeringly, the failure rate fell to 9%. And then they've repeated this experiment multiple times. It's now been taught at San Jose State 4 times. And the results have kept improving. 9% is pretty small, but I think the latest version, the pass rates fell to, the failure rates fell to 4%. So they just kept improving it over time. And so much so now that this experiment has spread to the entire California State University system with edX, where they're teaching this course across many campuses. We're also working with community colleges in blended learning pilots. Here in Massachusetts, we've worked with both Mass Bay Community College and Bunker Hill Community College. And here you see Professor Jamie LaRue, who took an Introduction to Computer Science course from MIT and used it in her community college class at Bunker Hill. And there again, by blending the classroom, you get the content from a MOOC, or from an online course, and you treat it like a new age textbook. Why should textbooks be this heavy bundle that you carry around with text on it? An online course is a new age textbook. It's got videos, it's got exercises, interaction, gamification, online. It's a multimedia engaging experience. So I think calling the textbook gives it short shrift, but unless I call it a new age textbook, you really won't get the impression of the usage model. And so the teacher, so instead of reading a paper book, they go and read or learn from an online class, and then work with the teacher, much as the teacher would work with you when you had a textbook. And there's been a lot of criticism leveled at edX. One of those has been that, you're a teacher yourself, how could you replace teachers? With these online courses, the worry that this is going to replace teachers, and suddenly, we won't need teachers anymore. And then again, I really encourage people who think that or ask that to meet the people doing it, to talk to Professor Jamie LaRue from Bunker Hill Community College, or talk to Khosrow Gadiri, from San Jose State University. And when you talk to the instructors doing this, they will tell you that they've never felt more like professors and teachers than ever before. That standing up there and giving a lecture doesn't really connect you to the students. And Professor Jamie LaRue says that her students, with the material given in a textbook, many of them would never have passed the course had it not been for her working with the students to help them learn and understand the material. So far be it from replacing teachers, I think really what online learning will do is provide a new tool to teachers. What tools have we given teachers? The last tool we gave them was in 1862. Anybody want to yell out what was the last tool we gave teachers in 1862? A piece of chalk, a chalkboard. And now don't yell out PowerPoint, because it's not clear to me that PowerPoint was a tool that advanced the state of the art or reversed it. But either way, so we really think of this as a new tool that we're giving teachers to use as much or as little as they please. Many of our partners, the campuses are being transformed with blended learning, and one of the most aggressive has been MIT. Now, you would imagine that universities that are doing really well would say, oh, we're doing fine, why mess with something? But MIT is a crazy place, and messing with things is part of their DNA, and this engineering mindset of continually improving is part of it. And so they're completely transforming the campus and bringing in blended learning in a huge way. And already, 2 out of 3 MIT undergraduates is using the edX platform on campus in blended learning models. And it's not just to replace the lecture, but in many, many other different ways. So I'll give you an example of the solid-state chemistry course. So in the solid-state chemistry course, as I said, you can use this New Age textbook in different ways. So what the professor decided to do was, for a variety of reasons, the professor decided to lecture. So the first time he taught the course, he said, okay, I'm going to lecture. So lecture was not replaced. However, what he did was, whoever said that we should have 2 exams, a midterm and a final exam? I mean, whoever said that one time a high-stakes exam is the way to help students learn? I mean, whoever said that? Where is it written? One of it is that grading is hard. And when I teach at MIT, I give 2 exams, and because grading is hard, I have to pay for pizza and get all the instructors and meet together in a room for 1 whole day, lock it on the outside, eat pizzas all day, and grade. Now, we can't do that every week. I can't afford pizzas every week. But so we have these 2 big exams. But now with online learning and instant feedback, what he did was he had lectures, but instead of he got rid of exams. Just imagine at MIT, no exams. What he did was he made it worse, I guess. He made it a continuous exam. Or think of it as no exams or a continuous exam. So what he did was he said, look, here's the amount of work that you have to do. You can come in to this area, and you can solve these problems online. And when you're done solving, 28 or 48 problems, you're done. And you can do them as fast or as slowly as you like. And so it's like a continuous exam. You can come in and do these things whenever you want. And the results, again, were staggeringly good. So after the 5th week of class at MIT, they send out students what is called a freshman flag. It says that you're not doing so well, you're on the verge of failing, so you've got to change your behavior somehow. So with this model of continuous assessment, so traditionally in the past few years, anywhere from 30 to 50 freshman flags would go out to a class of, this is a required class of all freshmen, would go out, 30 to 50 flags would go out of a class of about 400 or 500. After it taught in this manner, 2 flags had to go out. Now, the feedback from the students was that, we have all these great videos online, and why are you dragging us into class at this time in the morning? So I believe this fall he's going to repeat the experiment and make some more tweaks and changes and not have lectures and have them do videos and instead go to more optional help sessions and so on. So really, what you see happening is experimenting with learning in various ways with the aim of trying to do better and better. Finally, in the last few minutes, I want to talk about research, the third part of our mission. And as I mentioned earlier, we are gathering the big data of learning. Okay? We are gathering just large amounts of data. since it's an online platform, it's hosted in the cloud, we are able to capture every mouse click, every answer entered. We know what they're doing at what time. We collect information, what's the background, what's the language, which country they come from. We know at what time of day they're accessing the material. We know everything. And so we're gathering this big data of learning and using that to learn how students learn and thereby trying to improve learning. So this is just a chart showing you the amount of data that we've gathered so far over time. And this is just in the space over the last couple of years. We've already gathered more than 3 billion records of data. So we are gathering terabytes and terabytes of data. And so we know for a learner, for example, let's say a student is working on a problem. And we know that they got the problem wrong 4 times, but they got it right the 5th time. We can tell between the 4th and 5th time, we can look at what the student did to get the answer. In some cases, the students went to the discussion forum, discussed it. In other cases, they may have gone to the textbook. Or in other cases, they may have gone and reviewed a video. So we know what parts of the learning experience are contributing to successful outcomes. We can tell whether this is uniform across all students. Is it tied to the ways, tied to certain kinds of students? So we can get all of this data and use this demographic and activity data to learn how students learn. So I'll give you one quick example. So let me just hide that from you and ask you a question. So lectures have been 50 minutes to an hour and a half long, usually. Whoever said lectures should be an hour and a half or an hour long? I think it was a matter of convenience, so we could start on the hour. Did anybody do a study that 1 hour was the right lecture length? I don't think that was ever done. Now, for videos, we can do that study. So Philip Guo was a researcher from the University of Rochester. So he came to edX and did a study. He looked at all the videos, video lengths, and looked at where the maximum student engagement was. So he looked at 5 million video watching sessions. Okay, this is the big data of learning. And he looked at a few courses from a number of universities, over 5 million watching sessions. He plotted the amount of time a student actually watched a video to the video length. So video length on the x-axis, longer and longer videos, and he tracked how long the students watch each video. So we know when, all this information. So the videos ranged in length from 1 minute to 1 hour. You want to guess what the optimal video length is? So I see a lot of numbers being yelled out. I did hear 6 as well. So the median length so this is student engagement on the y-axis, video length on the x-axis, and turns out that 6-minute videos are optimal. So before that, we had professors that would argue with me when I would say, keep the video short. I didn't know what it was, so I said 5 to 10 minutes. They would argue, they said, oh, no way. It's got to be an hour. You've got to engage the student, and learning keeps improving. And once they really soak up the content, they start learning towards the end. And many professors insisted on 50-minute videos. And we showed them this graph that showed that when videos were 50 minutes long, students were watching it for 2 minutes. They just moved on. And so now we can use this data and show all of us that, look, if you really want to improve student outcomes, then, or really improve the engagement of the students, keep the video short. So just one example of how we can learn. So with that, let me just touch on one last thing and then open the floor for questions. So if you look at websites and so on today, websites continually improve. So with Google's website, for example, many of you have seen this. When you go to Google, when you go multiple times, even in the same day, you'll see 2 different websites. It's not that Google is changing its website all the time. They're doing what is called A/B testing. They're constantly showing one website to some people, a second website to some other people, A, B. And then they look at which of those websites result in increased clicking on ads, for example. So they do this continual monitoring of the data to try to improve things. Now that we have an electronic platform, we can do this on the platform. And so about 6 months ago, we launched A/B testing on the edX platform so that instructors can now become continually, can become education improvers. I hate to say education engineers because some people don't like engineers, but you can continually improve education as an instructor. What you can do now, let's say you want to teach something, and I can't quite tell, should I teach it by recording a video? Should I have them go read text themselves? Or should I just pose a question with the Socratic method and tell them to go to the discussion forum and figure it out themselves? So what do you think is better? We have no idea. Well, what we can now do, the professor can say, okay, I'll implement those three choices. We have an authoring platform called Studio, also cloud-based. They can author each of these three choices. And the students are randomly selected into these, randomly picked into these three categories. And then I can, as an instructor, I can go and see which of them produce the best outcome through an assessment. So I can tell what is the best way to teach something by doing these online tests, much like we do tests on websites. And then I can pick the right one and then start having the right method to be the only method for most of the students. So we can continually improve the way we do things through A/B testing, and we've just launched that on our platform about 6 months ago as well. So with that, let me pause here, and I'm happy to take questions. I would encourage you to. I've been told that there'll be a couple of people standing with microphones on the aisles. You can line up at the aisles to ask a question, and so that they can get the questions recorded, and I'll be happy to answer them.
I guess I'm the lucky guy with the first question. So I think that the certificates and badges are really intriguing, and I know a lot of people are toying with that idea. How are employers responding to these certificates in the real world, or other universities for students who are doing it to try to perhaps get into a college or transfer schools? How's that sort of playing out? Do you have any information on that?
Absolutely. So the question is, if you pass an edX course, even if it's an online course, you're getting a certificate. Is there any value to this? Do employers care about this? So first of all, I want to point out that it's only been 2 years. And so our data right now is anecdotal. Many employers don't even know about this stuff. But so I'll use some anecdotal data. But hopefully over time, we can get more statistical evidence. So data we've seen is on edX, when you have a learner gets a certificate, with one click, they can post the certificate on the LinkedIn profile. That's one example. And we've had examples of learners that have posted their certificates on the LinkedIn profile that have then gotten calls from potential employers, and they found jobs. And they credit their edX certificate with the employer having found them and them having gotten the job. Even in India, we worked with a company called Aspiring Minds, where they post learner certificates in their employee database. And there are 500 employers that work with them to scan the database. And what they're saying is that the employers are looking for edX certificates. And particularly in places where there is no clear currency. So let's say, for example, if I'm educated from the University of Timbuktu in some nation, and Adobe is out there and interviewing people, you'll see someone has gotten an A in a software as a service course from UC Berkeley. I want to say, wow, I want this learner. And so we're seeing many, many such anecdotal stories of learners getting promotions or jobs through these certificates. Yes? You can go ahead and ask the question. I'll repeat it. A great and challenging question. The question was, if I were a student and I passed the circuits course, and then I showed up to MIT as a student, would I have to retake that circuits course? And it turns out that MIT and other universities are grappling with this very issue. MIT admitted 3 students last year. 2 of them who had taken edX courses. And the performance in edX courses was a key factor in them getting into MIT. So Amal Bhave was from Jabalpur in India. Batushig was a student from Mongolia. They both got into MIT, and both had aced the circuits course. So MIT will have to grapple with this issue this year, They ace the circuits course, and the question is, will they be made to take the course again? And I'll tell you for sure in 6 months, because it's happening as we speak. But my answer would be the discussions I've heard, it just doesn't make any sense to make them take the course again. It's cruel. Instead, what you do, I think instead what you do is you can say, all right, you look at the online course and you look at the campus course. In the campus, they do one physical project involving physical components. So maybe what I would do is, again, what I would do, not MIT, what I would do is say, okay, why don't you do that physical lab, and if you complete that physical lab, I'll assume that you passed this course. That's what I would do. But we'll see what happens in 6 months. Yes?
Of the two parts. Of the 7,000 students who got a certificate, one of the approved certificates at the end, how many of them have been able to translate that into actual college credit at a university? So that's the first question. And with regard to those certificates, how do you ensure that the person who gets the certificate is the person who actually did the work?
So the first one is, of the students who are getting certificates, are they translating to credit? And today, in about 2 years, as I said, we've had 2.5 million learners, and they've signed up for a total of 5 million, over 5 million course enrollments. And we have already issued more than 200,000 certificates. And so that still begs your question, which is, okay, so are those certificates translated into credit? And there is no systematic approach to get credit. However, many universities have announced that they will give credit for edX courses. So for example, JFK University in California, they've looked at edX courses, they've approved a certain number of courses, and if a student goes there in the university and has had a verified certificate from one of these courses, they will get credit at JFK. And many other universities have begun to do that. The next question is, with a verified certificate, how do you know the learner is who they are? So the verified certificate, what we do is we partner with a company based in Newton out here called Software Secure, a great company. So we partnered with them. What Software Secure does, they already work with a number of schools and universities around the country on online assessment. So for the verified certificate, what we do is we have the student use a webcam on their device, take a picture of their face, and take a picture of a state-issued ID. And then that gets shipped to Software Secure, where it is verified that they are who they say they are. So the verification is person identification, which verifies that the person matches the ID, the face on the ID, and the name matches the name on the ID. So we are doing what is called person authentication. What we are not doing is activity verification. So we know who they are. So they are who they say they are. However, we don't check for, with a verified certificate, we don't check for, when they do the exam, for example, is someone whispering the answers to them? We don't check that. Now there are ways to do that too. The Software Secure, for example, will do virtual proctoring. They use webcam technology to watch the student as they are taking the exam and so on. There are other challenges in India, for example, where we have 300,000 students in India. Electricity goes away, on average, maybe once in 2 hours. And so you're taking an exam and suddenly electricity goes away. What are you going to do? So it's hard to continuously monitor in many countries. So there are challenges with actual activity verification. Yes?
Hi, good morning. St. John's University, New York. My question actually follows the same theme as the previous two speakers. Do you have any research to point out how national accrediting agencies such as Middle States Association or the American Bar Association, how they are accepting MOOCs? We are very interested in exploring this for the various reasons that you've outlined, but we do see this as a barrier. Thank you.
We are very interested in exploring how MOOC credentials can be translated into credit. There is no systematic approach yet. Certainly the middle various accrediting agencies are looking at it, the government's looking at it. A number of foundations are looking at it. The Markle Foundation stopped by edX yesterday, and they're interested in finding ways to create competency tests. That way you can learn anywhere, but maybe you take a competency test at a proctored center. So there are many ways in which people are looking at this. There is no solution yet. We'd like to see a solution, and my prediction is that something will happen, in the not too distant future, and we ourselves are working on it. The other thing might be that maybe employers will bypass the whole thing. A certificate or a degree is a signaling mechanism that tells employers that this person who's got this degree, purportedly knows something. And so if employers begin to believe that these portfolio of credentials with the certificates and so on already means something, then they may not care so much about degrees. And in fact, in the software industry, even at edX, we have about 40 software engineers. Several of them don't have a degree, and we don't care. And many companies hire people based on what they know and what they've learned, not based on their degree. And that may be the ultimate answer. But I think the future will tell us where things are going to be. Yes. The question is, could you tell us a little bit more about your partnership with Google? What is Google doing, and so on? So we are not working with Google on analytics. So edX has all the data. We own the data. The real privacy issues here, and so it's our data. edX and our university partners analyze the data. Our partnership with Google has multiple dimensions. One is that they're an open source partner. They have a team that is helping build out the open source platform. So they've contributed many, many technologies to the open source platform. Among one of them is single sign-on and authentication. They've also integrated Google Hangouts into edX. There are many other mechanisms they're integrating into the platform. That's one. Second is they've also built on Google infrastructure something called CBX. So you can author a course on edX Studio, and CBX will take the XML form that we spit out. CBX will take that and render it and play it on Google infrastructure. Google has also taught a big data course on that infrastructure using the edX interface. So there's many, many aspects to the partnership. But not on
Terrific. We have
no
one time for
sharing.
one more question.
Good morning. Dave Ravichandran from the University of Rochester. You talked about the green tick mark and how the machines can automatically evaluate exams and questions and whatnot. Are there any plans to open up the process of teaching the machine so that the community can build domain-specific knowledge for evaluating specific questions in specific domains?
Let me understand the question. So you're saying is there any thought to opening up the platform so anybody can contribute to the content?
Contribute the process of the machine being capable of evaluating specific domain answers.
So if I understand the question correctly, all the code is open source. So anybody can go in and either take the machine learning technology that we've built and use it for whatever they want, or they can also add features to the platform. Towards the end of this year or later on this year, we will also be launching MOOC.org, which will be a site where we'll be opening up the authoring. So anybody can, it's sort of like a YouTube for courses where anybody will be able to author a course. Anybody will be able to take a course. Right now, on edX.org, we have about 50 partners who author courses. But everybody can be a great teacher. And so the question is, why not open it up so anybody can go author a course, like anybody can upload YouTube videos. So that is something that we are working on as well. All right, with that, thank you all. Thank you very much.
Thank you very much, Anant.